In this video, we'll go on to look at some more of the homework problems, these ones dealing with function values, and we want to write a linear function for the line that passes through those 2 points or has those 2 function values. So we recall that f of 2 equals -2 means when x is 2, y is -2. F of 1 equals 1 means that when x is 1, y is 1. So we're going to label these x1, y1, x2, y2. We're going to use these values to first find a slope. M is equal to y2 minus y1 over x2 minus x1. My y2 is 1 minus y1 is -2. x2 is 1 minus x1 is 2. And so we end up with 3. 1 minus -2 is 3 over 1 minus 2 is -1, or a slope of -3. From here, we're going to write the equation in point slope form. Y minus y1 is equal to m times x minus x1, picking either one of the 2 points. If we pick the point that has positive coordinates, it might be a little bit easier. So this time I'll pick x2 and y2. So y minus 1 is equal to the slope -3 times x minus 1 also. Next, we're going to distribute -3x. Then -3 times -1 is +3, and that's equal to y minus 1, add 1, add 1, and we get y is equal to -3x plus 4. And that is our final version. We could also write this function notation: f of x is equal to -3x plus 4. And so that does it for number 21. We'll go on to number 22. First, identify the points. F of 5 equals 7 means when x is 5, y is 7. F of -2 equals 0 means when x is -2, y is 0. We're going to first calculate the slope. M is equal to y2 minus y1 over x2 minus x1. y2 is, okay, I didn't label them yet, I'll do that now, x1, y1, x2, y2. So y2 is 0 minus y1 is 7, x2 is -2 minus x1 is 5, and we end up with -7 over -7, which very importantly, negative divided by negative is positive. 7 over 7 is 1, and so we have a slope of 1 there. We're going to next write the point slope form. Y minus y1 is equal to m times x minus x1, and picking either point, we'll pick the point on the left. Y minus the y value of 7 is equal to 1 times quantity x minus the x value of 5. And that's our point slope form. Y minus 7, distribute now. 1 times x is really just x. 1 times -5 is -5. We'll add 7 on both sides, and we get y is equal to x plus 2. And that is our slope-intercept form. Again, if we want to write in function notation, it would be better written as x plus 2. Okay, and so that is going to do it for these 2 problems. We'll scroll down and do some of the other types. Okay, so in exercises 27 through 30, we need to tell whether the data in the table can be modeled by a linear equation and explain. So there are 2 possible explanations. If yes, then there must be the case that the slope through every pair of points has to be the same. Remember, a point is made up of two coordinates, but a pair of points is made up of two sets of coordinates. So if this data, or the data in that particular table, can be modeled by a linear equation, then it must be that the slope through every pair of points has to be the same. In the case where it's no, then that means the slope through any pair of points is not the same. So in the first one, in order to have the data be modeled by a linear equation, then the slope through every pair of points, every conceivable pair of points, has to yield the same slope. But all we need to show that it is not modeled by a linear equation is to find any pair of points for which the slopes are not the same. And I should say any two pair of points. And for every two pair of points. Alright, so let's take a look at what we have here. So in the first one, we go up by 2, we go up by 2, we go up by 2, we go up by 2. That's great. From -1 to 5, we're going up by 6. From 5 to 15, though, we're going up by 10. 15 to 29, we're going up by 14. 29 to 47, we're going up by 18. What this means is that the slope through 2, -1, the first pair of points, and 4, 5 is 6 over 2, which is 3. But the slope through 4, 5 and 6, 15 is 10 over 2, which is 5. So the answer to 27 is going to be no, because the slope through two pairs of points is not the same. Through the first pair of points, the slope was 3. Through the second pair of points, the slope was 5. Alright, so the next one, number 28. As we go from -3 to -1, we're going up by 2, up by 2, up by 2, up by 2. From 16 to 10, we're going down by 6. From 10 to 4, we're going down by 6. From 4 to -2, down by 6. -2 to -8, down by 6. Well, you can see here that the slope through any two pair of points is always -6 over 2, which is 3. -3. Alright, so let's go on to another example. We go up by 1, we go up by 1, here we go up by 2. Now it doesn't necessarily mean that we have a problem just because it does that. When x goes up by 1, y is going up by 0.2. X goes up by 1, y goes up by 0.2. When x goes up by 1, y goes up by 0.4. But notice 0.2 over 1 is the same as 0.4 over 2, and so the slope between every two pair of points is the same. And finally, number 30. We have 1, we go up by 2, we go up by 4. Here we go, y's values go down by 3, down by 3, down by 3. Now even though the y values are going down by the same amount each time, the x values are not. So the slope through the first 2 points is -3. But the slope through the second 2 points is -3 over 2. And the next one would be -3 over 4. So the slope between two pair of points are not the same, and so we would say that number 30 is a no. Alright, so that's going to do it for this video and this set of examples or exercises from the homework.